So now we're going to talk about assessing normality. Whenever we're using the t-distribution and other distributions, there's an assumption that the data looks roughly normally distributed. To check that that is true, we're going to use what we call QQ plots. It stands for quantile plots. The textbook drill actually goes over how to do a normal quantile plot, and I put the page number here in case you want to learn how to do that by hand. For the most part in class we'll do this using Jamovi. However, Jamovi creates a quantile plot, which is a little bit different than the normal quantile, but we'll interpret it the same. There are a couple of different methods that you could use to check for normality in your data set. The first one would be just creating the histogram. The issue that we have with that approach with our kind of data is that usually we work with very small data sets because we're still doing some of these problems by hand. And when we have like 5 observations, well, it's hard to have a histogram that looks normal. You could do the option in Jamovi for the density, and that actually looks a little bit better than a histogram. Your textbook doesn't cover it, but we do have that option. I'll show it to you when we move into Jamovi. Or you could do the QQ plot, and I'll show you how to interpret that. So here I have an example of a QQ plot where we do meet normality. What are we looking for in this plot? So the line for the graph, that needs to be at a 45-degree angle. If it's not a 45-degree angle, we probably will have issues. The other thing you need to look at is the little dots that represent your data set. Those needs to be closely aligned to your line. If you have dots that are really out here, way away from the line, that usually indicates you have outliers, which is a extremely large value or an extremely small value. It could be a data entry error. It usually tells you that you need to go back and look at your data. Or it could be a real value from your participants, but it's definitely an outlier. It's going to cause issues. And we want our data set to be normal so that we could do a hypothesis test using the t-distribution, and we meet the assumption of normality. So here I have 2 examples of when it's not going to be normally distributed. So look at my line, not quite at a 45-degree angle. The dots are it's kind of crazy. Look at that one. That's an outlier for sure. Look at this one. It kind of wants to be close to that line, but it is not quite there. So, and you can see that it's not quite at the 45-degree angle. So here we have 2 examples where they're not close to that line. And that's going to tell us that our data set is not normal. Okay, so now we are in Jamovi, and I use this data set from the Triola textbook. They are body temperatures, I believe, in Fahrenheit, and it's definitely a continuous variable. There's 2 ways that you can get a QQ plot. It depends on what you're doing. Let's say you're not necessarily doing a t-test, but you still want to check normal. So you would go into the Analysis tab, Exploration, Descriptives. I would drag my continuous variable into Variables. I have 2 menus here, Statistics and Plots. So I'm going to open Plots. Let's start with looking at the histogram. I had mentioned because we have small data sets, it's hard to look at it and see whether we have normality. So this does not help me a whole lot. I could choose to do a density, and I could say, well, it's roughly normal. What if I go ahead and just did my QQ plot? Well, there's not a real pattern. It's not extremely close to the line. You could say it's roughly normal. So I created this new continuous variable to create a new QQ plot. We're going to go to Analysis, Exploration, Descriptives. Let's drag it here. QQ plot. That looks pretty normal, like it's very close to the line. You can see because we have more observations, and it's not that many. We just have 12. It's easier to look at it. Let's see the density, what it would look like. Oh, that looks pretty normal, even in histogram. Well, actually the histogram doesn't help that much, just the density. But that's essentially what we're looking for in the QQ plots. There's a second way to do our QQ plots, and that would be under the t-test. The thing is, you don't always check normality just in t-test, but in the section where you are using the t-distribution, you can also do it there. So it would be analysis, t-test, one sample t-test, the continuous variable, and it's going to be over here where it says assumption checks, QQ plot. So this is the body temperature one. Let's exit out. Analysis t-test, one sample t-test. Let's do our second continuous variable. We're going to go to assumption checks. It will do the whole thing. It will do the t-test. You could ask for the confidence interval, but you can also ask for the QQ plots. There's another way to check normality, which is this one. We just don't cover it, and I'm just going to leave it